I'm Chris. Welcome to Warrior. This is the next episode of our special AI series where we're talking to cutting edge decision makers and innovators in the world of AI in the U.S. military. We're lucky today. We have a real cutting edge innovator. It's called In Charge AI. We have the CEO and the founder. What we have here is AI at the cutting edge, ways to power AI, create collection and analytics at the tactical edge, something the military's had its eye on, gosh, for years. Let's welcome our guests, our CEO, our founder, our innovator. Thanks for being here, man.
Yeah, it's a pleasure to be here. Thanks, Chris.
Well, I understand there's a potential technology being discussed, looked at by the U.S. military. Tell me what your innovation does. How is it different than what the military services are able to do right now?
Right. So at Encharge, we are building extremely energy efficient chips for AI inference. And of course, AI inference, that is the part of AI where you are actually running and using AI to do all kinds of things. Those could be, perception on all sorts of sensor data. It could be interacting with human users and providing, sort of responses based on reasoning capabilities and controlling through those all sorts of different bits and pieces of assets and infrastructure. So we are building the chips that will run that computation. What's critical about our chips and why I think there's a lot of interest in them by the Department of War is because they are extremely energy efficient. We exist as a company because we had a major breakthrough actually in my lab at Princeton. I've been a professor at Princeton University for many, many years. And that allows us to do AI computation at, sort of the core operations at something like 20x lower energy. This has been demonstrated in chips, in fact, in complete architectures and, sort of full systems that are running AI workloads. And that's very important to a lot of different applications in the realm of defense. It allows us to do more and better perception that in many cases can be embedded directly inside platforms that are airborne, that are spaceborne, those kinds of things. It gives us the ability to leverage AI in environments where network capability may not exist, and so you can't go and communicate to a data center. It's important to have that AI capability right in the hands of a warfighter, as an example. And it's also important where, for example, we want to be able to control and coordinate swarms of assets, things like drones, for example, and we want to be able to do that in ways that are reasonable and scalable for human operators to interact with. It could be through natural language interfaces. It could be through other kinds of control commands, but which allow you to scale from maybe controlling one or two drones, as an example, to maybe controlling 20 or 100 drones. So lots of critical applications for running the AI right there at the edge. And that's really limited in many cases by both the power that it takes to run that and also the kinds of models and AI workloads that can be run and integrated into the defense applications.
Well, Roger that. Gosh, you hear a lot about analytics at the tactical edge. You hear a lot about AI only being as effective as its database, reliability. You don't ask much about power sustainment, yet that seems so relevant from a tactical perspective. It calls to mind the Air Force's Golden Horde program, where munitions in flight are able to share information and adapt to new targets. Let's discuss this in almost a tactical sense. How might this work in a scenario? Is that about right when you have potential weapons or unmanned systems kind of performing that collection and analytics?
Yeah, so if you look at that kind of an application, AI opens up a range of really high value uses for the military. As an example, in these kinds of systems, munition systems, you will typically now have multiple different kinds of sensors that can detect things at long wavelengths and short wavelengths, things that are better for detecting through fog, things that are better for detecting in various kinds of obfuscated environments. So you'll have a whole range of different kinds of sensors. You want to fuse their information together so that you can get as complete a picture as possible. And now you want to do processing on those fused data streams. And typically you'll want to do those right inside these platforms, inside these munitions, as an example. And because you're dealing with these fused data streams, that processing has to become more and more advanced Our ability to do more and more accurate target recognition, target detection
Right.
has to be better. And in fact, even after some sort of an intervention has been taken, some sort of an action has been taken, we'll now actually also want to do assessment of what the impact of that intervention was. So there's all kinds of perception requirements here that significantly can leverage AI, but that also expand the requirements and ways in which we want to use AI. At the end of the day, these systems are thermally limited, as an example. And so the more you try to compute and the more power that compute dissipates, the more you're either limiting the mission lifetime of this particular operation, or you're limiting how much compute you can do. So the ability to sort of leverage and access all of this AI in this kind of a platform, which has this sort of constraint, thermal constraint, power constraints, and so on, really determines how much you can take advantage of this, sort of ever increasing AI capability.
Excellent. Well, gosh, I'm really interested in the power application because that's part of what I understand makes you super unique. And then I'm flooded with a million questions about the algorithm. So a couple more questions. But in terms of a form factor and a power sustainment, what is your firm doing that's innovative and different to enable that longer duration of power? Because that's so critical. You hear from soldiers all the time, I just need batteries, right? Because I'm forward deployed in an austere environment for X amount of time.
Yeah, so this really comes down to the fundamental technology. It turns out that in AI computation, we do a lot of this particular computation called matrix multiplications, essentially. And it turns out that these matrix multiplications are very heavy and costly to compute. Our innovation, which came out of my lab at Princeton, allows us to do those computations at about 30x lower power than you would using the state-of-the-art digital chips that you might get from Qualcomm or NVIDIA and so on. And it does that by relying on something called analog operation, where digital assumes that your signals are zeros and ones, which is great if you've got a lot of operations being done and hundreds of millions of transistors doing them, and they've all got some noise. You want to have some nice separation between those signals. And that's the reason a lot of the industry moved towards digital computation. But you can see very clearly here that we're leaving a lot of efficiency on the table because we're not representing all of these signals in between as we're doing these extremely computationally expensive matrix operations. And so we figured out a way to now do this operation in the analog world where you can get that efficiency back. The big challenge is you need to make sure that you're not susceptible to noise and all sorts of variations and things like that. And that was really the big breakthrough, figuring out how to do that for this particular operation, these particular linear algebra matrix multiplication operations. And then from there, building a full architecture around that, the full software stack around that, that lets you run very diverse, very wide range of different kinds of AI workloads that are relevant to the defense space, but also other enterprise and consumer applications.
10-4. Well, from what I understand, the AI at the tactical edge is paradigm changing in terms of an ability to perform the analytics in the case of, say, the Army, the Air Force's ABMS, and the Army's Project Convergence. This idea of taking multiple input from different sensors, aggregating the information, performing the analytics, and pairing that sensor to shooter. So, how much longer can your at the edge AI enabled chip sustain or extend that time? Then I have to ask about layering and defending AI.
Yeah, it's not just about how much longer can it do it. In many cases, this is about enabling capabilities that you couldn't have had otherwise. Let me give you an example. We talked at the start here about putting advanced AI capabilities in munitions, whether it's in a missile or something like that. Well, listen, that sort of a platform is very constrained. It's a closed environment, and so it has thermal limits. And that's often the compute is hitting up against those thermal limits. So if you want to be able to do perception, taking all of the sensor data and making sense out of it to do better target recognition, target detection, post-intervention assessment, those kinds of things, you're going to just need AI that is below a power threshold so that it meets the thermal requirements of this sort of a system. That's one example. Another example is there's a lot of cases where you want to run AI, but you don't have access to, wirelessly communicate to some data center. That could be because you just don't have that network connectivity. It could be because you're in an environment where connectivity over the network is not safe. And so now you need to be able to run these operations directly on perhaps a, sort of cell phone form factor kind of device that, a warfighter has got on them. Listen, you couldn't otherwise do that kind of analytics and that kind of assessment across these devices unless you had the capability to do it at low power, which would put it now on this device. The other example is, if you want to have a human operator, control now swarms of drones,
Yeah.
this is now where, how do you scale from controlling one or two drones to scaling to controlling a swarm of drones? You want to be able to sort of interact with and adjust flight plans and adjust mission plans using very simple methods. For example, natural language interfaces. Well, that requires these drone platforms to now have advanced perception, but also potentially reasoning capabilities, where now they can interact with a human operator, get certification on a new mission plan, and respond accordingly. So there's all sorts of applications. This isn't just about, extending the battery life from, 1 hour to 48 hours. It's also about all of the new kinds of capability that open up because of what AI gives us, all of the virtues of AI, but now being able to do them under the constraints of that tactical edge.
A 10-4 on that. Well, you mentioned a couple things that caught my attention. One, you hear a lot about thermal management with batteries, right? This idea of running into a wall where operational effectiveness can get compromised by thermal inconsistency. That's huge with hypersonics and all kinds of munitions.
Right.
But the other thing that you mentioned that really caught my attention was data layering. You talked about a discriminating ability, right? The idea of target verification, using algorithms to filter incoming sensor data, find those moments of relevance. You don't necessarily need a database, and AI is, of course, only as effective as its database. I'll ask you about subjective stuff in a minute. But what happens if it comes across something that's not there? How is it able to make that verification, and how can the reliability be improved?
Yeah, I mean these are all, sort of problems that better AI workloads, better AI models, and algorithms really have great potential to solve. And in fact, it's not just AI alone. A lot of this is going to require also better sensors. At the end of the day, both the better AI and the ability to process more sensors, perhaps by creating a fusion of those information streams, those sensor streams, at the end of the day, it demands more compute capability. And so, with the roadmap that we're seeing in ways that, more sensors, higher resolution sensors, better AI algorithms on the back end of those can add value to these defense applications. All of this is creating this demand that is, kind of rapidly exploding how much AI compute capability we want to put in the tactical edge in these devices. And of course, now you are limited by whatever the constraints are. We talked about thermal constraints. We can talk about size and weight constraints, which are important in a handheld device, and they're equally important
Right.
in an airborne device like a UAV or something like that. Sort of those are the constraints across which we want to create a real inflection and what kind of capability is available to the military.
Roger that. Well, gosh, a couple questions. One about data layering, right? You don't necessarily need the full library of Shakespeare to verify a target in an austere combat situation. So, how do you aggregate the necessary database to perform a specific function and then program those algorithms with agents to identify those objects of relevance, those moments of relevance in context? And that brings to mind this last question about context. One of the things that's really key is hardening AI against spoofing or intruding, right? One of the things I heard is, let's say an enemy will have a tank and they'll just put a poster over it. These were industry innovators, just very sophisticated, saying, well, the attempt would be in this case to spoof the algorithm so the positive verification can't be made. Well, aren't there then, and sir, you're perfectly positioned to address this, aren't there then more holistic algorithms that look at a number of variables in relation to one another to make that positive identification despite the spoofing? I'd love to hear you address that.
Yeah, so I think a lot of when we think about multimodality, it's really about, sort of having a more robust, a more complete picture of the environment. Now that's only one piece of it, so of course we want to be able to, do sort of, optical sensing. We want to be able to do radar sensing, all of these different kinds of modalities give us a multi-layered, multi-textured picture of the environment, which now you can process to be able to do your detection operations, detection tasks better. But of course, then there's also input that you can sort of combine with this from, human operators. So there will be
Right.
collaborations between, these automatic perception systems and also human operators that are on the ground. And so the extent that all of these different information streams can be used to construct better information and a clearer picture are all of the kinds of things that the sort of defense applications are really driving towards and are interested in. And this is where kind of the advances that we see in algorithms are kind of driving us towards and what our compute needs to be able to support. I'll give you an example. In AI, we've become very interested in these things called vision language models, which are able to take visual streams, but which are also able to take human language streams, natural language streams. And so you can imagine sort of analysis and analytics on an environment coupled with, sort of the visual sensors, but also human interpretation of those sensors can lead to better understanding, which then our systems can take better responses to. So these are, advances in AI, these vision language models, as an example, but which now we need to have the compute platforms, the chips, to be able to support in these very, thermally constrained, energy constrained, network communication constrained environments.
Roger that. That makes so much sense. And it relates to the last question I have, which is this question of AI's ability to make discernments and positive verifications of things that are otherwise more subjective, things that are less quantifiable, like that scenario where an adversary is trying to spoof the algorithm. How do you make that assessment? Isn't that to a degree where neural networks come in, or you can kind of make an approximation of something? I've been looking at some research with hypersonic glide vehicles and how they can become more penetrating by approximating the path or the location of a potential interceptor, that kind of thing.
Yeah, I would say, sort of security and secure operation, anti-spoofing or defense against spoofing is just one aspect of that. Is really a multifaceted problem. I think on the one hand, we want to be able to have very robust and spoof-proof hardware. And so you need to have security features built inside your processors. And that's something that Encharge and its processors and its sort of intentions to use these in defense applications has really prioritized from the beginning. I think another aspect of this is having multimodality for sensors so that if one
Right.
sensor is spoofed, the other one perhaps is not. But another aspect is also the protocols by which these AI
Right.
systems are used. You use them together, with human operators and human operators who have the right protocols so that you can give them, sort of the right capability so that they can present, kind of what they see, but can also present those in ways that are interpretable by a human operator and with which a human operator can then take action on or can provide inputs to so that the two systems can work collaboratively. And I think part of what, sort of enabling defense applications means is understanding the full technology stack and the full algorithmic stack for this kind of security, but it also means understanding the operational stack, right? The protocols that are involved here and making sure that these systems provide the right interfaces and the right capabilities for that full stack as well.
Roger, this is my last question. I'm glad you mentioned the layering, and I'm glad you mentioned the idea of stacking and protocol, because doesn't this, with sensor input from otherwise disparate transport layers that might not otherwise be compatible, you have this need to translate with the protocol and the interfaces. And that's where something like gateways can come in. So, to what extent are you working with a gateway, a sort of core computer system that can take these otherwise incompatible or divergent incoming sensor languages, or whether one's RF and one's GPS or one's some other kind of data link? How are gateways factoring into this?
Yeah, these are critical. And you find them both for different kinds of sensor streams, you find them both for different kinds of networks and so on. And, the sort of defense technologies have built up a lot of these capabilities to be able to connect the different networks, to be able to connect different kinds of information streams. So when we think about now AI as being this new capability, this new processing capability, a new brain, it needs to be able to plug in at the right interfaces with, sort of those gateways. So they need to really work in a collaborative way. That's what makes the software stack of our chips so critical. It's important that this thing can integrate into the different ways that these subsystems are talking to each other. That's typically done through, hardware, but also the right software protocols. And so making sure that the, chip has the right interfaces really at the software level to be able to connect into these full systems, and to make sure that we're then collaborating with the right, sort of users to be able to operationalize and transition into operational use those complete systems, is really critical. And so, the systems that we have in the defense space for a lot of these reasons look very different than the ones that we have in, the traditional commercial space. And so there needs to be, sort of close collaboration with colleagues in the different who are very closely tied to the different defense applications to ensure that we're meeting that alignment and doing it, in a way that really provides effective benefits in the tactical edge.
10-4. Well, we full circle. We end where we began. I love that you said collaboration because the Air Force Research Lab's Golden Horde, that's what it is. Munitions in flight, collaboratively, autonomously sharing information to adapt to a different tactical scenario, perhaps weather, perhaps a moving target, something of that nature. So if anyone was looking for the absolute cutting edge and the brilliant work that's being done on the forefront of AI, you want to talk to this guy. This is Encharge AI. This is the CEO and the founder. We want to thank you for sharing your expertise. And let's end with one last thought, which is what's next with this? There's some experimentation, some testing. What might be the next step with this? Because thinking of it, the tactical implications, you don't want to overstate it or sound sunshiny, but almost limitless in terms of what this will enable from a purely tactical standpoint.
Yeah, I really think that there's two things that we have to push on simultaneously. So it's not one next step. I would say the two things that we have to push on are real now, as we have the fundamental technology, as we have these chips, really working with those colleagues in the defense space who are embedded in those applications to really drive that transition into operational use and make sure that they're talking to the systems in the right way, that they're calibrating to their sensors in the right way. But the other one is, and you alluded to this, the capabilities are endless, but that means that you need to continuously push the advanced technology development as well. And so the other piece here is to make sure that we do keep pushing the development of the advanced versions of this technology while we provide that on-ramp into the actual defense applications by working with colleagues who are embedded in the applications.
Well, thank you so much. Excellent. I'm sure you make Princeton proud, and I'm sure we'll be hearing more of this when we follow what the military services are doing with the AI applications. I mean, the Department of War, it's such a focus right now. So thank you for contributing a great level of expertise to our series, sir.
Thank you very much. It means a lot.